My name is Paul. I'm the founder of Allbesmart, technology company that is part of this consortium, 5G Auto. 5G Auto is about the development and testing of 5G V2X technology, and is led by Altis Labs, together with the Beira Interior concession Global Via, so A23 highway in Portugal, Allbesmart, and the Instituto Politécnico Castelo Branco, and is funded by Compet in Portugal 2020. So as I mentioned, the objective of 5G Auto is to investigate and develop innovative solutions for CITS based on 5G V2X infrastructure. So we are main focus on the advanced V2X based on 5G beyond release 15. So we are looking and taking advantage of the longer range, the higher density, and very high throughput that 5G V2X brings. And this is aligned with the requirements of coverage in Portugal. As you know, by 2025, 95% of the highways should be covered by 5G. So we should take advantage of this to enable CITS services. So one of the main goals and results of the 5G Auto project is a CITS platform system that works as a centralized back office that allows the road operator to configure alerts that automatically will appear on the onboard application or in the infotainment systems. So the communication is done through 5G V2X, and we have implemented several CITS use cases that have been tested. And I'm going to now to show some videos that are the results of the pilot done at A23 highway that is managed by Global Via. So the first video I'm going to play. So showcases several CITS use cases. So this is the Gardunha tunnel, an important infrastructure for the interior of the country. We have implemented several roadside units across the highway. And since part of the project also addressed the tunnel, and we don't have geolocation inside the tunnel, we start to implement these Waze beacons to provide geolocation that is critical for V2X to work. So these Waze beacons provides the geolocation inside the tunnel. This is the very interior central control center where we have integrated the CITS platform and where the road operators can create alerts in a very easy way. So you can see the infrastructure that was deployed across the highway. And in this example, the road operator will create an event that is a roadworks warning, for instance. So there is a roadworks warning in this section of the highway. So we can configure the meters or the warning distance, the maximum speed that is allowed in this area. And in the calendar, you can control when this alert is going to be visible. And then the antennas will start broadcast the CITS messages that will be picked up by the onboard unit and will be visualized by the driver through onboard application. That for testing, we are using, in the first approach, a tablet connected to the onboard unit. And you can see here a real deployment with the roadworks warning in the highway. We work very close with our interior Global Via that allowed us to do these real deployments. Here is an emergency vehicle that is getting into the Gardenia tunnel. Geolocation is possible through the beacons, as I've told you. And here you can monitoring the presence of the emergency vehicle. And we are inviting drivers to slow down and drive with caution. Other use case is an accident, road accident warning. So this accident was configured through the CITS platform. and then the drivers that are approaching the accident area will receive the messages and the distance that you are from the accident. So all these messages are standardized by CITS and we follow the standard. We also participate together with Copernicus initiative by ESA on the integration of our platform with the Copernicus system. So we'd like also to showcase that the CITS platform can also get inputs from external sources and not just by the events that are configured by the road operator. So Copernicus has Europe's eyes on Earth, has sensors that detect wildfires, for instance. This is open data that we integrate with our platform. Just a quick example what is possible. In this case, we are in the interior area of Portugal. There is a lot of wildfires. And imagine that is a wildfire 20 kilometers up front. And this wildfire, the smoke is detected by the satellites from Copernicus. So this technology is available by open source. Copernicus makes this data available. You can see here a map of the Fundão area. And then if there's a wildfire, the broadcast automatically start sending emergency evacuation alerts that invites the drivers to escape from the highway before goes to the dangerous area. Another example, okay, the see-through, the V2X connectivity allows high throughput between vehicles for safe overtaking. We have here an example where the driver is in a rural road where typically overtaking could be dangerous. And the V2V connectivity that 5G allows is going to be tested here. So the driver will switch to the camera of the car that is in front. So this circle, and you can see that if the camera of the car that is in front, and then it will start the overtaking in a safely way. As you can see here, these are two vehicles from Global VR doing the testing. And yes, Altis Labs also, of course, participates in the and deploy roadside units across the highway that have been used to broadcast these messages that were configured through the CITS platform. What else? Yeah, here integration with the car infotainment system. So far, you have just look at the tablet that you are using for testing, but in the later stage of the project, we managed to integrate the messages with infotainment systems of Tesla Model 3, and you can see here these are actually the messages received through our technology. So the car is approaching roadworks area before the Gardunha tunnel, and the distance that you are from the different alerts. So this is a new step that allowed us to integrate with a real infotainment system, in this case for a use case related with road alerts. Again, the importance of have coverage. We have roadside units inside the tunnel that allows us to test this technology. Okay, so what else? Interoperability tests are very important. So we participate in several ETSI plug tests together with the 5G Automotive Association. So Allbesmart as a part of the CV2X plug test vendors. We were to Germany to do testing with different manufacturers of roadside units and providers of CITS technology. This is very important to guarantee interoperability. Yeah, some images of the outdoor testing done in Germany with the big players of the industry. Okay, to finalize, and since today I saw several presentations using OpenAI interface, I'm going just to show you our product that is called OAI Box, developed by Allbesmart, that in part was used in the 5G auto project, and the idea is to facilitate the use of OpenAI interface. So you just Google OAI Box, but I will show you how it works. So here you are testing our own Genode B that runs OpenAI interface. So inside this computer, you have a distribution of OpenAI interface that is very well tested by Allbesmart. Allbesmart is one of the key contributors to the OpenAI interface and a member of the OAI Software Alliance. We have here the core network, the Genode B, running in a commercial PC connected to a USRP, an external antenna, and you are doing here cell coverage testing with real equipment. And also the idea is to test the stability of OpenAI interface. You will know that OAI is not easy to use. And our team, after years of using OAI, we launched this product to facilitate the use of OAI. So here you have a cell coverage of 150 meters. You have stability. The code remains open source. So you can see OpenAI interface over there with a real iPhone 14 Pro standalone. This is standalone technology for 5G. Here we only have 40 megahertz, so we are reaching 100 megabits per second. Establishing a FaceTime call between two user equipments using OpenAI interface. So this brings OAI to another level that you can exploit in your research. So I invite you to use, and then we expose the parameters. So the signal interference noise ratio, physical layer parameters from the core, from the Genode B. In this case, Tiago is moving away from the Genode B, and you can see that the degradation of the signal interference noise ratio. So you see that the cell coverage is around this area, and the signal interference noise ratio goes almost to 0. So our dashboard export data that usually is very hard to get from OAI. Here the OAI lost the connection.